Lesson 6.5 on scale drawings is very similar to the last lesson in that we're going to use proportions to help us solve problems. Now, scale drawings are like a road map. This is the one I always think of because when my family went on trips, I was the one that usually ended up reading the road map for my father to tell him how far one city was from the next. This is before the GPS and all that came into play. Now, a scale drawing, like a road map, is a two-dimensional drawing that's similar to the object it represents. Scale drawing. A scale model, now we're going from 2 dimensions to a model, 3 dimensions, is a 3-dimensional model that's similar to the object it represents. For example, the Eiffel Tower model that's out on the strip in front of the Paris, it's not the same exact size as the true Eiffel Tower in Paris, but it has the same scale in that the heights compared to the width of the base and such are in the same ratio as that of the actual building in Paris. Now, here's key: the scale of a scale drawing or a scale model. This is what gives the relationship between the drawing or between the model's dimensions and the actual dimensions. Now, by that I mean, if you're reading a map, typically there's a scale somewhere provided on the map that says maybe 1 inch represents 20 miles. It's what shows how you can compare the drawing to the actual figure itself, to the actual object it represents. So we're going to try it with an example right here. It says a map well, that's not right. A map has, there we go, a scale of 1 inch equals 5 miles. 2 towns on the map are 4.5 inches apart. How far apart are the actual towns? Well, this is where we use this part right here. This is the scale right here. 1 inch represents 5 miles. So I'm going to set a ratio of 1 inch to 5 miles. Now notice here I have the inches on top, I have the miles on the bottom. I'm going to be consistent with that because what I want to do is I want to set up a proportion so that I can find the missing measurement. In this case, the missing measurement is the actual distance between the towns. Now we know on the map they're 4.5 inches apart. We want the actual distance apart. Well, 4.5 inches represents the map. That would go in the numerator, 4.5. My unknown is the actual in miles distance between the 2 towns. I'll call that x. And I have my proportion, which I know how to solve. I multiply on the diagonal. I get x equals, now 5 times 4.5 turns out to be 22.5. You can double check the arithmetic, but that's it. Now how far apart are the actual towns? They are 22.5 miles apart. Okay, and we solved a problem using the proportion. Here's a couple more examples. It says a map has a scale of 1 centimeter to 4 kilometers. So we're going metric here. Use the actual distance to find the distance on the map. All right, so these are the actual distances. Notice they're in kilometers. We're going to find the distance between the, let's say, the 2 cities, whatever they might be, the 2 landmarks, whatever it might be, like I say. We're going to find the distance on the map. So what I'm going to do is I'm going to use this scale. I'm going to write 1 is to 4. Notice I have centimeters on top. I have kilometers on the bottom. So over here, I'm trying to find out how many, the distance on the map, how many centimeters would represent 2.6 kilometers. Notice centimeters on top, kilometers on the bottom. So I'm going to cross multiply. I'll multiply these 2 together. That's 2.6. I'll multiply these 2 together. That's 4x. Now in this case I have to solve for x. I'm going to divide by 4. And be careful with your arithmetic. It looks like 4 goes into that 0. Let's see, 65. It looks like 0.65. So that's not very big. 0.65, 0.65, and this would be in centimeters. Well, that one's small. This one's really going to be small because look how much smaller the actual distance is. So I'm going to set it up the same way. I'm going to go 1 is to 4 as, what's time we'll use y? Y is to 0.6. Cross multiply, 0.6 equals 4y. I'll divide both sides by 4. and I get y is equal to 0.15. So this would be 0.15 centimeters for the distance on the map. Now here's an example of a problem where they don't give you the scale, they're actually asking for the scale. It says Mike's map shows a bicycle route that is 112 miles long, but on the map the distance is 14 inches. What's the scale of the map? So what we want to know is, what's the scale? Like 1 inch represents how many miles, that type of a deal. So what I'm going to do here is I'm going to set up here the actual distance and the map distance here. I'm going to go map distance on top, actual distance on the bottom. Okay? Actually, if I want to find the scale for the map, maybe I'm going to, we'll just leave it like this. And then what I'm going to do, now remember, this is inches on top and this is miles on the bottom. I'm going to divide top and bottom to make that a 1 because I want to know how much 1 inch represents. So it's kind of like the unit amount, the unit price. In this case, 14 divides into 14 goes in one time. 14 goes into 112. What is that? Is that 14 goes in? Is that 8 times? That's 8 times. Oh, if I could do arithmetic today. So according to this, my scale then is that 1 inch represents 8 miles on the map. Okay. Now the next example, this is a model. This is more of the 3D shape here, but we set it up the same way. It says that the model of a sailboat has a scale of 1 to 20. That means on the model, 1 unit is worth 20 units on the actual sailboat. Now they don't give us inches, they don't give us miles, but these would be the same units because otherwise they would have listed the units there. So these could be inches, could be miles, doesn't matter. In this case, it says the actual distance, or the actual sailboat, is 32 feet long. Now remember, this is the model up here. This is the actual sailboat. So if the actual sailboat is 32, we want to know how long the model is. So I'll call that x. Well, here we go again. Cross multiply. I get 32 equals 20x. I'm going to divide by 20. So I'm going to get x, I'm just bringing it right up here, I'm going to get x equals, well, let's see, 20 goes into 32 one time, and 12 left over, that would be 0.6. I'm going to write it as a decimal, 1.6. So how long is the model? The model is 1.6, and this is in feet, so this would be in feet long. That kind of makes sense. A model boat would be probably somewhere in the 1 to 2 feet, depending on how big the model is, I guess. Anyway, set up your proportion, cross multiply, divide, solve, and you'll be able to solve these problems out. Just be very consistent with your correspondences. That takes a lot of practice, practice, practice.